Indirect collisions, type 1, both moving. So we have to remember when we have indirect collisions that when they are moving, generally they're both moving at an angle either towards each other or away from each other, and one is catching up. And when we're looking at before and after, we're going to now have both I and J come into play here because they're not just moving in the horizontal I direction. So we're going to start by making out our diagram and then our table for before, mass and afterwards. And again, we'll apply our principle of conservation of momentum and our Newton's experimental law of restitution to solve our simultaneous equations for our speeds before and after for both balls or both spheres. Now, in this case, we have to look at what information is being provided to us. Well, we're given the I and the J directions for their initial velocities. And this question's nice because it actually sets up the diagrams, the vector diagrams, showing you the I and the J and therefore showing you the resultant. And that would always be something that I'd recommend that you do for any of your diagrams in these questions and indirect collisions. So you can see whether they're both moving with a positive I and a positive J direction. Often students miss out on the negative direction. So if they're coming, say, towards each other from the left and from the right, one might have a negative I or a negative J value, and you have to make sure you factor that into your table. So here we can see clearly they both have a positive I and a positive J when filling out our table. Now the second thing that we're given here is that after the collision, so if we underline that, so after the collision, the spheres are moving in a parallel direction. So if they're moving in a parallel direction after the collision, well, we know that any two things that are parallel to each other will have the same slope. So of course, we're going to have to look at getting the slopes for both the spheres afterwards and then be able to equate their slopes in order to solve for what we are looking for. So the first thing we're trying to do here is find E in terms of K and then prove that K is greater than or equal to a third. So in order to get E in terms of K, we're going to have to use this information about the fact that they are moving parallel to each other after the collision. Okay, so let's start with the diagram. So if we have our two spheres on collision, then we have one moving with a velocity of 6I and 2J. So if I resolve that vector component there, let's use a green, then we have our 2I or 2J I should say, sorry, and then we have our 6 in the I direction, and same here then we have theta, so we have 4J and then we have our 2I. So again, if we were looking at angle beforehand versus angle afterwards, that can often be useful. Okay, so now we're going to make out our table, and in our table we'll do our before, our mass and our afterwards. And this time we have to make sure it's in terms of both I and J, and then we'll have a look and see, well, which is conserved. So if we're looking at this diagram here, you can see that it's going to be the J that is conserved and then the I that's going to change direction. So in other words, if they're colliding off each other, their J directions are the ones that are staying exactly the same because the line of centre is through the I. Okay, so see here, the lines of centre is through I. So if the line of centre is in the J direction, then it would be the J that would be changing and I would be conserved. So we say star J is conserved. And we'll look at a question in the next example on that, okay? So I'm going to pause it and you're going to complete the table. So for the sake of the table, I'm just going to refer to these as sphere A and sphere B, just so I know whose velocity is which at the end, okay? Okay, so for beforehand for sphere A, we were given that the velocity was 6I plus 2J and it had a mass of m. So because the line of centre is in the I direction, we're saying that the J is conserved, so therefore Pi is going to be the new velocity in the I direction, and in the j direction it's still going to have a velocity of 2j. For b we have 2I plus 4j, and its mass is km, and again we'll call q for the new velocity in the I direction, and the j is going to stay the same because j is conserved, so that's going to be 4j. So the first equation we're using is our principle of conservation of momentum. So we'll have m1u1 plus m2u2 is equal to m1v1 plus m2v2. And therefore, filling in all of our values, we have m times 6 plus km times 2. We have m times p and km times q. And again, as I said, if they were approaching each other from the left and the right, we'd have to be careful because one of those velocities would end up being a negative then. So if I divide across by m, that leaves me with p plus kq is equal to 6 plus 2k. Now we can see obviously that our answer is going to be in terms of k here. So we don't normally have these unknown values in these questions, so this time we actually do. Okay, so that's going to be our first equation. So the second equation, then if I go on to the next page, is Newton's experimental law of restitution, which obviously can be found on page 51 of our maths tables. So our Newton's experimental law of restitution then is V1 minus V2 is equal to minus E U1 minus U2. And then if I fill in those values, that's P minus Q is equal to minus E times 6 minus 2. So we have P minus Q is equal to minus 4E. So we call that equation 2. Okay, so let's line up our two equations then. I'm going to multiply the first one. So we'll get rid of the P, so we'll multiply the second one here by minus 1. So that gives me P plus KQ is equal to 6 plus 2K. And if I multiply the second one by minus 1, we have minus P plus Q is equal to 4E. And then that leaves me with KQ plus Q is equal to 6 plus 2K plus 4E. And if I could take out Q as being common, that leaves me with K plus 1 equals 6 plus 2K plus 4E. And then dividing across by K plus 1, that gives me 6 plus 2K plus 4E all over K plus 1. So that's the velocity in the I direction afterwards. Now if I sub Q into either of my equations, so I'm going to sub it into 2, it might be a little bit easier to work with. And then I'm going to have P minus Q, so 6 plus 2K plus 4E all over K plus 1. Rid of that bracket. And then that equals minus 4E. Okay, so we're going to have to try and get P on its own here. So P then will be equal to minus 4E plus 6 plus 2K plus 4E all over K plus 1. So the lowest common denominator there is K plus 1. So that's minus 4E times K plus 1 plus 6 plus 2K plus 4E all over K plus 1. And if I multiply out my brackets there in the top line, I have minus 4KE minus 4E plus 6 plus 2K plus 4E all over K plus 1. Okay, so tidy that up a bit. I can see I have a plus 4E and a minus 4E, and it's not going to get any neater than that. So that leaves us with 6 plus 2k minus 4ke all over k plus 1. Okay. So now we have our velocities afterwards in the I direction. We now need to look at the fact that we were told that they were parallel. So after the collision, the spheres move in a parallel direction. So we're going to need to write out our velocities for afterwards. So we say after, and again I called them A and B. So A's velocity, the sphere of mass m, was equal to, so if I call that velocity 1, that's 6 plus 2k minus 4ke all over k plus 1 in the I direction plus 2j. And the second velocity, so the velocity of the sphere of mass km, or sphere B, has a velocity of 2k plus 4e plus 6 all over k plus 1 in the I direction plus 4j. So to get their slopes, we know that a slope in the I and the j direction, there's my I direction, there's my j direction. And if I want to get a slope, well, it's opposite over adjacent. Okay, and therefore it's j over I for our slopes. So in other words, our slope is tan theta. And if they move parallel, then their slopes are equal. So let's say m1 is equal to tan alpha, where m1 will be A. And therefore m1 is equal to our j, which is 2, divided by our I, which is 6 plus 2k minus 4ke all over k plus 1. And of course I'm dividing by a fraction there, so I'm going to turn it upside down and multiply. So we'll have 2 times k plus 1 over 6 plus 2k minus 4ke. Now I'm not going to bother multiplying out the brackets there because I can see already that there's a k plus 1 in B there. And if I'm going to be equating these slopes because they're parallel, then those k plus 1s will cancel. So B then we'll call slope 2, and that will be tan beta. So for the second slope, then we have m2 is equal to 4 divided by 2k plus 4e plus 6 all over k plus 1. So again, if I turn that upside down and multiply, we'll have 4 times k plus 1 over 2k plus 4e plus 6. So because the slopes are parallel, then we just need to equate these two. So if m1 is equal to m2, then we have 2 times k plus 1 all over 6 plus 2k minus 4ke is equal to 4 times k plus 1 all over 2k plus 4e plus 6. So if I equate there, k plus 1 goes into k plus 1, 2 will go into 4, and that's going to give me 1 over 6 plus 2k and that would be equal to 2 over 2k plus 4e plus 6. Now if we go back to the question, what is it we want to do? Well, we want to find e on its own. So I'm going to cross multiply here. 2k plus 4e plus 6 is equal to 12 plus 4k minus 8ke. And if we get e on the left hand side, well, that gives me 8ke plus 4e is equal to 12 plus 4k minus 2k minus 6. If I take out e as being common, I have 4 plus 8k, and that's equal to 2k plus 6, and then e, if I divide across, is equal to 2k plus 6 over 8k plus 4. And of course I can simplify that down by dividing the top and the bottom by 2 there, and therefore that gives me e is equal to k plus 3 over 2, k plus 3 over 4k plus 2. Now, I had a student one year do this in a really nice, short, neat way, but of course most students will actually solve the problem this way, hence this solution video is done out this way. But if any of you have it done out in a nice, neat, short way, I'd like you to post your solution in the comment section below this video so we can see, have you found a quicker way of doing this problem? If not, this is the kind of traditional way that most students in the country would actually solve it, and therefore I always will do the traditional way for you, okay? All right, so the second part of the problem then, if we go back to page 1, says prove that k must be greater than or equal to a third. Now, what do we know about what we've just solved? Well, it's e, our coefficient of restitution, and therefore our coefficient of restitution must always be between 1 and 0. In other words, it must be less than or equal to 1. So therefore e, we've just found, is k plus 3 over 4k plus 2, and therefore that must be less than or equal to 1, and therefore k has to be positive. Why must k be positive? Well, it must be positive because we can't have a negative mass, and our mass of the second sphere was km. Okay, so therefore I'm able to multiply both sides across by the denominator there without affecting the sign. Okay, so it's really important, obviously, in inequalities that you check, is the denominator positive or negative before you multiply across both sides by it. Otherwise, you'd have to multiply across by both sides squared. And therefore, I have k plus 3. If I bring everything to one side, it'll be minus 4k minus 2, less than or equal to 0. That gives me minus 3k plus 1, less than or equal to 0. Therefore, I have minus 3k less than or equal to minus 1. And therefore, if I divide across by minus 3, I will change the sign because dividing by a negative sign changes the sign. And therefore, we have k must be greater than or equal to a third, which is what we wanted to show. Okay, if it was a range in between 0 and 1, then we would obviously start with 0 is less than or equal to e, which is less than or equal to 1. But we didn't need to do that in this case because we just wanted to show k was greater than or equal to a third. Okay, so breakdown of marks. Well, this second part of the question was quite straightforward and easy, and therefore we ended up actually getting 10 marks for this. So that was a nice handy 10 marks. And even if you had gotten E wrong in the first part of the question, well, you'd have gotten your 10 marks out fully if you could show whatever you had. Now, obviously, you wouldn't get k greater than equal to a third, though. Now, if I go back, the other marks then on the previous page, where we were getting 5 for E is equal to k plus 3. And then we had 10 for our two equations. So we had 5 for the first one, 5 for the first one, and 5 for the second one. So we had 5, 10, and then we had 15, 20, so 25 in total. So we have 25 marks. Okay.